Oh, hello everybody. Welcome to my dissertation demonstration I'm doing for you on YouTube. So, basically, I'm like, I'm not sure if people actually like to watch or read a whole like 12k words, whatever, 12,000 words. So instead, I was like, I'd prefer just to watch a video demonstration of it. So that's what I'm doing here. Wahoo! So, basically, my demonstration, the title, my dissertation, the title was investigating using investigating settlement generation using flood fill algorithms. So the idea sounds very fancy, but actually, this is a really good example of what a flood fill algorithm is. Anyway, before I get ahead of myself, basically, I'm just trying to create a city from a diagram such as this, where different types of buildings will be placed on different colors. So there's a black line around the perimeter here. That is what I am hoping to be like the walls of a city or something like that. And then the red line here, these are all like the roads. And then in like the blue squares, maybe there'll be like more upper class housing, bit more posh, bit more raw. And then green could be, I don't know, lower class housing, and then the light blue could be like entertainment district. Oh, you could do so much this stuff. But basically, the idea is that I create a program. We can input these buildings, and then it'll place on these colored points. Now, flood fill algorithms. What the heck is that? Flood fill algorithms are an algorithm that basically allows you to get one pixel, and then it finds a pixels next adjacent to it that have a similar characteristic. So in this instance, color. So color is the similar characteristic. So you may start off on this top here, and then you'll be like, okay, so let's get a completely different color. Let's get a darker green. Yeah, darker green. And so it'll be like, okay, well, we have a green here, then the two next to it also are green, so we're going to add this to the shape of the red. There are two red pixels here that are not the correct color. So yeah, these two pixels here are red. They're not the same characteristic. These two pixels are. So this pixel will add these to the shape. And the flood fill algorithms are most famously used in paint buckets. So as you can see here, is paint bucket tool in picture editor. There, it uses a flood fill algorithm to map out that shape of the same color, and then change its color. In my example, instead of changing the color, it just takes the shape and places buildings on each of the pixels. So let's get to the actual thing. All right, so let's go to a whole different thingamajiggy. This is the plane of existence that the city will be built upon. If I go here, you can see there's a load of little handy dandy little scripts here, and these are the different types of flood fill algorithms. You've got a brute force, not flood fill. Brute force is just a general name for an algorithm that's not very smart. It just keeps on hammering at it, keeps on brute forcing its way through. I have a full wave recursion. This type of algorithm basically takes the pixel and then gets the pixel north, south, east, and west of it, and then from that checks the pixels around it. If they're the same, add it to the shape. If they're not the same, don't add it to the shape. Now, so these are two different types. One's a recursion, and that's one type of programming method. Another one is linear, which is another type of programming method. We don't have to worry on that. Span fill, basically what it does, instead of going the pixels adjacent to it, it does a line by line, so it kind of draws up the picture like this. So if I quickly and smartly get span fill GIF, something like this. So see, it goes along the lines. Oh, so fancy. And this is an example of four way, so it just kind of keeps on spreading out like a little wave. And then next, this one is my favorite, but it's also the worst, is a walk based fill. And this is like, imagine you are on on the actual pixel itself, and you're walking around with a paintbrush, and it's almost like you're mopping the floor. And because you don't want to walk on where the mop you've already mopped, because you'll make it dirty and you'll get your feet wet because you mop the floor there. You want to not paint the pixels you've come from, so you kind of just walking in a line, painting the pixels as you go along, and you kind of start on the perimeter and then slowly spiral your way into the middle. That's kind of how I like to think of it. It's not as good as the other ones because this one basically takes a lot more logic because you have to kind of almost envision yourself as the actual painter or the mopper as you're painting all the pixels as you're going along. Yeah. And so here we have an array, a mesh array. So if you notice here, the size here is 6, and then the size here is also 6. So this stores the type of buildings I want to place in different spots. So for example here, I've got castle wooden battlement. I don't think I really want to have that one there. Let's buildings real quick. Then castle. Which one do I want? I want something like a wall. Does this work? There we go. And then I think this one down here, one with rocky archway. Let's just put this one here. Rocky archway. Yeah. Okay. So let's take element 0 here. This will go on the black pixels, which are also element 0. So they kind of link up together like that. Anyway, that's the boring technical stuff. Ooh, yucky programming. You want to see the colors spawn a building. Whoa, okay. So here we are. What did I use walk base for? I do not want to use that because that will take a longer time. We're going to use the speed one, which is the span fill. Very, 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 very quick. So when I press the space bar, it worked. Yay. And so as you can clearly tell, it looks exactly like a city. Not really. But anyway, as you can see, I've got like a cobblestone path that's placed on all the red pixels. Due to how the meshes spawn, like they actually spawn the cobblestone paths on a corner. Anyway, it's a bit frustrating, but it's all spawned correctly. Anyway, and then I've also got houses. Here I've got these little wooden huts that are within each other. I've got some little towers and some circus tents. So this, if you want your fantasy, Lord of the Rings, this is the magic wizard tower where Gandalf would be. And this is where the big bears on like the unicycles would be, I assume. That's Lord of the Rings, right? And then this is like the swampy marsh, because they're like on stilts. That's like the jungle rainforest. I have no clue. And here's the taverns. There are a lot of pubs in the city. People like pubs a lot. And then we got the walls. Wow, look at that. Great big wall. Massive wall. And then we got like entrances and out of the whole thing. Yeah, so that's what I spent. Ooh, and then you get funky patterns like this. Oh, look at this. You get like the double wave. That's actually kind of cool. Kind of nice. Look at this. Woo, woo, woo. Anyway, I'm getting sidetracked. Whoa, amazing. I know. Thank you. Anyway, so that's basically making a thingy with a thingy. That's my dissertation. So if you don't want to read the words, if you want a more technical explanation, it'll be in the PDF. But don't feel like you have to. Anyway, hope to see you all soon. I mean, I'm assuming. I have no clue. I have no clue who's watching this. I'm assuming family's watching this. If you're family, hope to see you soon. Kiss, kiss. Bye-bye.